Hey everybody, this is Tyler Lay again, and today I'm going to talk about how modern cement is produced. I know that gray magic material that makes concrete. As I told you before, concrete is the second most used material in the world. And so it kind of makes sense that it's going to cost a lot of energy and effort to make it, right? Well, cement, one of the important ingredients in concrete, the production of cement consumes approximately 6% of the world's energy. I know, but it's the second most used material on the face of the earth. That's pretty amazing, though, that cement helps us make concrete, right? 6% of the world's energy, though, is used to make cement. And the cement industry itself produces, or I guess you'd say the concrete industry, produces 5% of the global man-made CO2 emissions. So there's kind of a carbon footprint with it, right? Kind of a lot of energy that goes into making it, but it's so useful, and it's everywhere, and it's long-lasting, and we don't get things in life for free, okay? But remember, one of the big reasons why cement production, Portland cement, modern cement production, is such an issue is we have to calcine. What's calcining again? It's where you take something and you heat it up to break it apart. And the most common one is to talk about calcium carbonate. We take limestone and we heat it up to about 2,300 degrees Fahrenheit, and you make lime and carbon dioxide gas. What's that called again? Yep, calcining. But that only produces about 60% of the CO2. We still need energy and CO2 that's required to mine, to produce heat, and then ultimately to grind the clinker, I'll talk about what that is, the cement up into smaller particles. Okay? But there's kind of an interesting statistic that for every 1 pound of cement, it produces approximately 0.9 pounds of CO2. So it's about 1. So if you can reduce a pound of cement in your concrete, you're producing a pound of CO2 emitted to the atmosphere. That's beneficial. So let's talk about all the raw materials that are used to make clinker. And you're like, what's clinker? Don't worry, it's part of cement. Well, we'll use limestone, usually to try to get calcium oxide. We'll use sand. Sometimes we'll use clay or shale to sometimes get aluminum. We need that. Slag, we'll use that to get iron. What's slag? That's a waste product from the iron industry. We'll use fly ash. That's a waste product from the coal industry as well. Or we'll use other junk. Cement kilns are known for burning all kinds of stuff, like medical waste, like tires, all kinds of stuff that we burn. And we use all kinds of different fuel sources to actually to make this happen. Sometimes we'll use coke, which comes from coal. Sometimes we'll use natural gas. Okay? So these are all the raw materials that we use to make clinker, which is part of cement. Now, what we care about is to get oxides, like calcium oxide. And we usually have 60 to 70% of our cement is made up of calcium oxide. And if I'm going to use cement chemistry shorthand, remember that's the shorthand that really makes normal chemists mad? Ha! For calcium oxide, I'm going to call it C. Silicon dioxide. Between 18 to 22% of our modern Portland cements are made up of silicon dioxide. And again, the cement chemistry shorthand for that is S. Aluminum, Al2O3, about 4 to 6% makes up our modern cements. That's A in cement shorthand, cement chemistry shorthand. And then iron, that's again 2 to 4%. That's why our cement's gray. That's why our concrete's gray. It's because of the iron. That's an F. And these are what's called the major oxides because they make up the major amount of the chemistry of the cement. Major oxide. What are they again? Calcium, silica, aluminum, iron. Calcium, silica, aluminum, iron. That's the major oxides. And they all combine in clinker to produce something called C3S, which is alite. Oh, I've talked about alite before. That's the good stuff. C2S, B-lite. That's the not as good stuff, but you form B-lite before you form alite. Then C3A, which is called aluminate. This helps us with our early age stiffening. And C4AF, which is called iron. And people don't know a ton about C4AF. But we'll talk more about all of these coming up when we talk about hydration. But it's good just to kind of know how everything loops together. We also have something called the minor oxides. These are less than 5%. Magnesium, for example. And in cement chemistry shorthand, guess what? It's just M, sodium, and potassium. These are called alkalis. We'll talk more about them coming up. There's good things about alkalis, and there's bad things about alkalis, just like everything in life. Then there's sulfates. Sulfates are something that we add after the fact, but they're really important for controlling our setting. We'll talk much more about that when we talk about hydration. These, though, in cement chemistry shorthand, are S-bar. Yeah, we're really making the chemists mad now. S-bar. Now, to make all this, we make it in a kiln, and I'll explain what that is coming up. But it's a large oven that spins. It's got bricks on the inside, and it spins, and inside of it, you make clinker, right? Clinker are actually what comes out of the kiln. They're these little small black gray pellets. They look like volcanic rock. They actually glow when they very first come out of the kiln. They're amazing. And I'll show you a picture in a second. And then the clinker is pulverized. You beat it up and you grind it with gypsum and also limestone dust. Now, this is something that's been used, at least in North America, over the last 10 years or so. In Europe, it's been used before that. And people like to add 5 to about 15% limestone dust. 5 is where a lot of folks are at. Why? Because it's inert. Some people say it does something, but it doesn't do a lot. But you can add stuff. It's like adding gristle to meat. You can't tell it's there as long as you add it in small amounts. Anyway, this gypsum, though, is really important. Why? It's important for setting and early age strength gain. And I'll talk more about what that means in hydration. All right? Let's show you some pictures. What do you say? This may look really scary, but this is awesome. This is the end of the kiln. Yeah, that glowing lava-looking stuff, that's clinker. See these little ball shapes? That glowing rock? That is clinker. That's the raw stuff that comes out of the kiln. See this? This big fire-looking thing? Yeah, it really is fire. They actually shoot fire into the kiln. It's amazing. What comes out? These glowing rocks. We actually try to cool them really rapidly. And they look like this once they're done. This is what clinker looks like. It looks like volcanic rocks. Okay? And if you cut them and polish them and look inside of them, actually these are acid etched. Okay? This is what they look like underneath a stereo microscope, just an optical microscope. It's beautiful, isn't it? These blue rounded shapes, that's B-lite. What's B-lite? C2S. Not as rapid strength gain. But out of the B-lite forms A-lite. What's A-lite? These are these angular looking particles, these light gray, A-lite. That is the good stuff. That's the fast reacting rapid strength gain. And this matrix that everything's buried within, that is C3A and C4AF. It's kind of buried within everything else. So this is one of these clinkers that they're going to break up, okay, and try to make into these little smaller particles. Pretty crazy, right? This is what it finally looks like. So when they grind, what do they add again? Gypsum. They add gypsum. What else do they add? Limestone. Why do they add limestone? Because it's inert and it lowers your CO2 footprint, should lower the cost, but it's inert. It's recycled material. But why do we add gypsum? It's really important. It's for setting. So let's try to explain this process in a little bit more of a formal way. These are the steps to make cement. We're going to kind of go over them at first, give you like a general idea of what happens, and then we're going to go on a virtual cement tour. It's pretty cool. I'll show you the link on how to get there in the notes at the bottom. You just have to click at the bottom and it'll show you more information. When you go to make cement, the first thing you have to do is you have to gather up all your raw materials. That's your rock, your sand, your clays, your fly ash, your iron, whatever you need. And you say, well, how do I know? What do I need? Well, you actually have to look at the chemistry of what you have. Most of the time, cement plants are built on quarries, okay? You usually think of quarries making aggregates, but in this case, they're making cement. And you can sell cement for more than you can sell just plain aggregates. So you have to look at what chemistry you have, and you have to find other materials to add to that to get the chemistry you need to make the cement. You have to put everything in the kiln and then cook it. And then what comes out the other side? Clinker does. Not cement, clinker. It's not cement until the end. So you choose your blend of your actual materials based on your chemistry. You're going to crush that material, and then you're going to blend it up. You're going to mix it up really, really, really well. Get it all intimately blended together. Then you're going to send the materials to something called a preheater tower. Why do you do that? Well, it gets all the water off, number one. And number two, it starts the calcining process. It starts heating up the materials. You're basically using the flue gases from the cement production to preheat the materials that's going to go inside the kiln. Then ultimately, it's going to go inside this kiln, this big, long, rotating shaft with fire coming out of one end. I know, amazing, right? Then you're going to rapidly cool the clinker right when it comes out. Why do we do this? Well, it's going to make it more reactive. We're trying to grab certain things called polymorphs. These are chemistry. We're trying to make the chemistry just stop. We're trying to make it be much more disordered so that we can, again, make it more reactive. Then this clinker, that's the rock I showed you earlier, we're going to grind it with gypsum and limestone. And then finally, it's cement. It's not cement until after it's been ground with gypsum and limestone. And I'll tell you why coming up. And again, this is from PCA. And if you want to search the virtual cement plant, that'll get you there. Or you can look at the notes below. But again, links change all the time. Let's go to a virtual cement plant. You ready? So you start out in the first step, gathering all your raw materials together. You start out in the quarry. And this comes around here, you hit this button, and boom, you blow it up. It's fun to hit the button. It's like, grrr, 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 blow up the cliff. And then you can see, oh, look at this. They come in, the dump trucks come in, and they pick it up, and they pick it up, they pick it up, and they haul everything off to the crusher. They dump these large boulder-sized materials in, and they crush it into smaller boulders. They may crush it a couple times to get it smaller and smaller and smaller. Now we get to this point where we proportion and blend the materials together. Now they're showing a pretty cool process where materials are coming in, right? And they're seeing what the chemistry is, and they're changing the blend because of this. It doesn't look quite like this. It's actually pretty amazing. They actually use nuclear gauges to measure what the chemistry of this material is on the fly as it's coming into this process, so they can adjust on the fly to get the chemistry right. They can add in the other components to get the chemistry exactly like they want to go inside the kiln. And after they get the chemistry right, then they have to grind it up more. Grind, look at that. Goes around there and grinds it up smaller and smaller and smaller and smaller pieces, right? And then we get to go to the preheater tower, okay? And in this case, we're going to dump the materials in, right? And the heat coming out of the kiln is going to come up. And as the heat comes up, it's going to boil off any water. Okay, so it's going to dry the materials out, but it's also going to start heating them up. Because if we can get them hot when they go inside the kiln, the material doesn't have to spend as long inside the kiln. And when it's in the kiln, that's where all the energy is being expended. So if we can minimize the time in there, we can make cement faster, we can spend less energy. Everyone wins from that, okay? So then we go to the kiln itself. And the kiln is pretty awesome, okay? This intense fire is coming out of one side. All the material is dumped in, and it's actually changing chemistry all along the way inside the kiln, right? And at the very end, it's what we want. Here it is. There it's being dumped in. Look at that. Oh, yeah. Amazing, right? Totally amazing. I love this because it's so cheesy, right? I mean, they can make it better, but I just think it's awesome. So after the clinker is done coming through the kiln, we have to cool it, okay? So we have to cool it off so that it comes out and there's air actually being sent up through here, okay? And it's trying to cool it as fast as we can. We're actually going to use that, again, that heat to preheat the material, and then we're going to mill it. So our clinker is shown in white, and we actually have huge steel balls, and this is pretty amazing. There's a big, long, spinning cylinder, and it's got these steel balls in it, right? And these steel balls are going to beat up the clinker, beat it up. They also add the gypsum, they also add the limestone here, and they beat it up, and there's usually two separate cages. But you can see that there's this perforated kind of layer inside here, and see this little stuff that looks like it's snowing? It's not snow, that's the cement coming out. The cement is coming out of this grinding thing. So there's perforated, there's holes right here where the grinded powder actually comes throughout, okay? Falls through, and they keep it, okay? And then once they're done, they get to bag it up or ship it out in tankers, and we can use it. I know, pretty awesome, right? That is how modern cement is made. Thank you so much. Take care. Bye.